Now look at how modulation is done, right? So let's just imagine you have an information signal there. Information signal is what is given is a displacement versus time. So since this is your information signal, it would be corresponding to an audio frequency. Let's say the audio frequency is corresponding to 5 kilohertz. So you have a 5 kilohertz audio frequency. Now what we have here is it's a unmodulated carrier wave. I'll tell you in a moment what you mean by modulation. But what I'm going to generate here is I'm just going to generate a high frequency carrier wave. So this is just a high frequency carrier wave. It contains no information here, right? What we want to do is we can't send the signal. The problem of sending the signal will be the antenna length is too high, and because the frequency is of very low frequency, you have a problem of interference as well. So in order to rectify the problem, the first thing I need to do is I need to increase the frequency to reduce the antenna length. So if I increase the frequency, let's say I'm increasing the frequency to 50 kilohertz. It's not enough actually, but let's just say I have a carrier frequency of 50 kilohertz. Now that carrier wave has got no information here. Why? Because here, as I see that I have a 5 kilohertz audio signal. Now the information in the 5 kilohertz audio signal would be at these times the displacement. At these times that is the displacement. At this time that is the displacement. At this time that is the displacement. And I have the information in a signal would be its displacements, that would be information, and its frequency. So these are the two informations that I have from a signal. So every signal, it would be the instantaneous displacements, the displacements at every point, every time, and the frequency. So how do I incorporate this information into the carrier wave? That process is called modulation. When you say modulation, what we're going to do is we're going to take a carrier wave, we're going to change the properties of the carrier wave. We're going to change the amplitude of the carrier wave, or we're going to change the frequency of the carrier wave, so that this carrier wave has the information from these informations of the information signal, of the audio signal. So we need to change the properties of the carrier waves, and I told you there's two things that you can change. You can change the amplitude, you can change the amplitude, or you can change the frequency. Hence you have two types of modulation called the AM or the FM, which is the amplitude modulation or frequency modulation. Now which signal are you sending? Are you sending the information signal or the carrier wave? You're going to send the carrier wave. You have to send the carrier signal. Now the carrier signal is sent, but if you just send the carrier signal without doing anything to it, it will not contain the information that was in your audio signal. It will just be a high frequency carrier wave which you can't hear because it's above your audible range. So what we need here is we need a method to actually uh, change the displacements or the information in the audio signal onto the carrier wave. For that, you got two processes, one is AM, one is FM. You are not learning what circuits can actually do it, you are learning what the process is all about. Now the process would be, let's check and see. That's your information signal, right? That's your information signal, and information signal contains information of displacements at various times. What I'm going to do in the case of AM, we're going to look at AM, is that you see the carrier wave there? The carrier wave has amplitudes, and the amplitudes are same because it's produced by an oscillator. Now this carrier wave or the amplitudes of the carrier wave is going to be vary. You see, I'm going to vary the amplitude there. Now how do I know how much to vary, whether to decrease or to increase and so on? It all depends on what my information signal is. If my information signal is of the information signal's displacement is small, then I vary the amplitude as such, or let's say the amplitude is as such. If you look at that signal or that position, that's the maximum amplitude. This is not to scale, so you'll actually find it difficult to understand how the scaling is done, but all that you need at the moment is I'm changing the amplitudes, right? And the changes in amplitude should contain the information in the audio signal. So how much to change depends on what is the displacement, So we want to look at two things. If you say change the amplitude, I want to look at how much. I need to change how much. How much do I change? And next question is how many times in a second? How many times? How many times in a second do I need to change in a second? So these two questions are actually answered by the displacement or the information signal itself. So how much to change, whether to increase very large or very small, depends on the displacement. How many times in a second to change depends on the frequency of the information signal. Just hold on there. Let's check and see what is amplitude modulation again. In amplitude modulation, what you're going to do is you're going to change the amplitude of the carrier wave so that the changes in the amplitude contains the information of the information signal, and the number of times you change would contain the information on the frequency of the audio signal. Okay, let's stop there and we go back and see there's two types of modulation. One is AM modulation or amplitude modulation and frequency modulation. In the case of amplitude modulation, as you notice, the amplitudes are varied, but the frequency of the signal is kept constant. So just remember, in amplitude modulation, the amplitude is varied and it's varied in synchrony with the displacement of the information signal. I can't just put anything there because I have to look at my information signal. But you don't need to do it graphically or anything. It's actually done by the circuits and uh, uh, the systems following them. So let's look at what is frequency modulation. In the case of amplitude modulation, you're changing the amplitude. In the case of frequency modulation, you're changing the frequency. You see, that is your information signal which has an amplitude and high frequency there. In frequency modulation, you keep the amplitude constants. Again, don't look at the scaling there. You keep the you keep the amplitude constant, and you're actually varying the frequency of the information signal. You vary the frequency. You see the frequency is, oh, the time period is getting larger, which means frequency is small there. The time period is small, which means that's a large frequency. So you actually you don't know what circuits are actually doing it again, but it is actually the frequency that is being varied here. Now, how much to vary? Why did I vary so much here? Why is the frequency very low? It all depends. How much to vary depends on the information signal. Again, questions of how much. How much to vary is answered by the displacement of the information signal and how many times, that's what, how many times is actually answered by the frequency of the information signal. What that means is, let's say you have a displacement signal like this. How much the amplitude varies or how much the frequency varies is given by the displacement signals. Let's say your audio signal is 5 kilohertz. If your audio signal is 5 kilohertz, then you are supposed to vary 5,000 times in a second. So you're going to vary the amplitude 5,000 times. So there's 5,000 variations in a second, or there's 5,000 variations in the frequency in 1 second. That's what it means by rate of change in amplitude or rate of change in frequency. How many times? We'll actually summarize them and see what is amplitude modulation and frequency modulation. So in amplitude modulation, the amplitude of a carrier wave is made to vary in synchrony with the displacement of the information signal, which means you need to look at the displacement of the information signal or your audio signal, and their amplitude is varied in synchrony. It's the similar word here, but instead of amplitude, you're actually changing the frequency. In amplitude modulation, frequency is kept constant. In frequency, amplitude is kept constant. In FM, amplitude is kept constant. Now, the change is how much. Again, the variation, this answers how much. How much amplitude is varied, or how much to vary the amplitude. The variation or change in amplitude of the carrier wave is a measure of the displacement of the information signal, which means the displacement of your information signal determines how much to vary your amplitude. Or in the case of FM, the displacement of the information signals determines how much to vary your frequency. Again, why do we need to do all this? Why not just change as and when I want? Because again, when I get back the signal, I need the information from the audio signal. So you need to know, oh, I've changed 5,000 times in a second for this part of the wave. So my carrier wave has changed, or the carrier amplitude has changed 5,000 times in a second at this region. That means that my audio signal was 5,000 hertz or 5 kilohertz. So again, to the rate at which means how many times. If your amplitude varies 5,000 times in a second, that means the frequency of the information signal is 5,000 hertz. Or if your variation, that actually variation has, we'll actually look at it. It depends on voltage and everything. So we'll look at it later. So the rate at which the carrier wave, the rate at which the frequency is varied, frequency of the carrier wave is equal to the frequency of the information signal. So if you want to get the frequency of the information signal, you look at how many times the carrier frequency is varied. If the carrier frequency is varied 5,000 times in a second, 5,000 times, then your information signal has a frequency of 5 kilohertz. So that's about of AM and FM. We'll actually go into detail later, but at the moment, that's your basics. Read the application booklet, and I think that